The CSAP demo application includes multiple projects. The first is a 3-node system with a single master that has no taints, meaning you can deploy services onto the master. The second project is a 6-node Kubernetes system with 3 masters, all tainted with no schedule. To upgrade these systems to the latest versions of Kubernetes, we'll use the csap host installer. To do this, we open up the host, select command runner, open the library, filter by install. A previous screencast covered using the csap host installer. In this instance, we'll use a pre-updated script that contains all the variables necessary to update the cluster. In this instance, the installer is using csap APIs. First is to retrieve an application definition for the host from csap dev01. It will do this using the csap agents REST API. The second item is to build the target host by aggregating 2 hosts, dev3 and dev20, with csap CLIs to retrieve the hosts that are defined in cluster name 1 and cluster name 2. The API is highlighted here using the csap model hosts. And the final step is to select the version of the csap platform that we're choosing to install. In this case, it's the 2106.1, which includes Kubernetes 1.21. With those settings configured, we'll go ahead and click Run. The connection tests have all passed, and now the application definition has been retrieved from the source and copied to all of the hosts being updated. Since several hosts are being upgraded simultaneously, all of the installers are being run in the background. And just like that, within about a minute, we've now kicked off the installers on all of the hosts being upgraded. To monitor progress, we can switch back to the actual demo application, select the Deployments tab, and then select Backlog. Here you can see the initial progress is displayed because the existing management agents were shut down on all of the nodes. Then the installer has kicked off. Within a minute, we should see those starting to come up. And so now we see nodes dev3 and dev20 have come up. It's worth noting that both of these nodes are single node Docker instances, so there is not Kubernetes being installed, simply Docker followed by a set of services. Since the installers, although they're running concurrently, they were kicked off sequentially. So the first node to come up is dev4, and we can see that the installation and upgrade is starting with the installation of Docker, followed by some core OS services. In this instance, it's worth noting that all of the Kubernetes services that are deployed on the first Kubernetes cluster actually are deployed on the master, which is dev4. And so now it looks like we have Kubernetes Docker being installed on 4, 5, and 6, and then on 7, 8, 9, 10, 11, and 12, we see Docker being installed, followed by kubelet. To track the progress of the installation, we can go ahead and look at the Kubernetes install starting on dev4. So it looks like it's kicked off. So to actually monitor the progress, we'll go to Services, Kubernetes Provider, select kubelet, and then Logs. And to view the deployment logs, we'll go ahead and select Start. So on dev4, we can see the package installation has just completed, and it's starting to pull the Kubernetes images. So dev4 is the Kubernetes master. Switching to dev5, we can see that we're also beginning the image pull step. This is important because it achieves as much parallelism in the install as is possible. Dev 6 also appears to be still in the repository add stage, so it hasn't quite installed the packages, but it's about to, and then it'll start pulling those images as well. Switching back to Dev 4, we can see kubeadm reset, so this is actually going to clean up any instances, and now it's actually beginning the kubeadm install. The actual parameters can be displayed. If we scroll up a little bit, you'll see the kubeadm init command, which is responsible for starting up the control plane. While the control plane is in progress, we can switch over to Dev 5, and you can see that it's polling, waiting for the master to be ready on node 4. If we switch to 6, it's probably just about there. It actually looks like it's still pulling the Kubernetes images. Switching back to 4, we can follow along and watch Calico come up. Once we see Calico fully initialized, we'll note that the install will kick off on the other node. And so now it looks like the node is just about to transition into the steady state on Dev 4. And if we switch over to Dev 5, it looks like it's just connected to the primary master and it's kicking off its own install. We can switch back to the backlog and monitor further progress as we go through it. With the availability of Kubernetes on the primary node, you'll see that the Kubernetes summary view has now reappeared on the left navigation. Now you can see that the worker has completed on 5 and 6. Meanwhile, the Kubernetes packages that were queued on the master are starting to begin their deployment. In addition to being able to observe the process through the backlog viewer, we can also look at the Kubernetes events and observe the changes as Kubernetes proceeds to deploy the containers. We can see the CSAP ActiveMQ Postgres services getting deployed. This will be followed up with the CSAP reference app. We can also check out the pod view and observe that we have the monitoring cluster is fully deployed. The log cluster is currently queued. CSAP test cluster is partially up. There's a few more services that will be deployed in here. And we can switch back to the backlog view to watch the finish. Meanwhile, on the 6 node cluster, which is in the second project, we can see that kubelet has now completed installing on all 6 nodes, and it's starting to deploy the services. And we can switch over to view that second cluster through the project tab, and then selecting the nodes. And now we see that all 6 nodes in the second cluster are deployed. And similar to the first cluster, we can look at the pods that are currently deployed. And slowly but surely, all of the nodes are being deployed. We can actually query the version of Kubernetes a couple of different ways. We can go to the host view, select Kubernetes, and verify that the correct version of Kubernetes is being displayed. So in this instance, we see 121.3, so that's great, along with the corresponding version of Docker. So just to highlight, Kubernetes is a 3-node cluster deployed in 4, 5, and 6. And we can also directly interact with those instances by selecting the node, opening up the OS Explorer, and then verifying that the version of Kubernetes is correct. And after a few more minutes, we're down to the final set of services being deployed on the second Kubernetes cluster. And a few more minutes later, you can see that the entire backlog is completed. We can observe and verify the deployments by switching to the pod view and ensuring that all of the clusters are deployed, metrics are being displayed. We can also go to the volumes view and validate that the actual data from Postgres is on the disk. And there's our Postgres data.